Well, hello class, this is Mr. Picard, your well-rounded math teacher. We're gonna get into a new chapter. Chapter 12 deals with possible outcomes and some probability. Hopefully stuff's a little bit lighter for you. We're gonna have a week of this starting Monday, and then we have 2 days before break. So we'll probably take a test that Tuesday before break, and we'll be done with chapter 12 and then into review for finals. So anyway, the counting principle is basically what we're going to be working with today, and then some other terms also. The number of possible license plates for a state is too great to count by listing all of the possibilities. It is much more efficient to count the number of possibilities by using the fundamental counting principle. Okay, so talking about events, we have 6 different events here. You have 3 letters, 3 different letters that you can use, and 3 different numbers, and we call them digits, whatever. How many letters are there in the alphabet? Well, there's 26, so we have 26 different outcomes for this first event, 26 for the second, and 26 for the third, and they don't affect each other. You can have 2 U's, 3 U's, whatever. Once you choose a U, it doesn't mean you can't use U again. For the numbers now, you would think it would be 9, but you can use a letter or numbers 0 through 9. So there's 10 different choices for each event here. Okay, we're going to talk about how you use these different events and come up with a number of possible outcomes using the fundamental counting principle. But first of all, let's talk about some other terms. Terms to be familiar with. Okay, first one, outcome. Outcome is this. Result of a single trial. Flipping a coin once results in 2 outcomes, heads or tails. Well, it would be a head or a tail, yeah. Sample space, okay. Set of all possible outcomes. Total possible outcomes when rolling a die is 6. Sample space would consist of the numbers 1 through 6. So if I flip this die here, I could get a 1, 2, 3, 4, 5, or 6. That's our sample space. Let's try it. If I get a 1, you guys have no homework. Sorry about that. An event, we talked about an event a little bit, consists of 1 or more outcomes of a trial. Rolling a die and flipping a coin would be 1 event. Events. Now, there's 2 different types of events. Independent events, where they don't affect each other. Outcomes of one event doesn't affect the outcome of another event. The choices of letters and digits to be put on a license plate, like we said before. If I choose U for the first one, that doesn't mean I can't choose U for the second one here. Or I could choose U for the third one also. So choosing one event doesn't affect the next one. So that's what we call an independent event. Now, a dependent event is just the opposite. One choice affects the next one. So dependent events, outcomes of one event does affect the outcomes or the outcome of another event. Choosing a piece of candy from a jar without replacing it, then choosing another piece of candy. So that would be an example of a dependent event. So we look at this problem here, number 1, and we're going to decide whether it's an independent event or a dependent event. A sandwich cart offers customers a choice of a hamburger, chicken, or fish on either a plain or sesame seed bun. How many different choice combinations of meat and a bun are possible? So the 2 things we're looking at are meat, choice of meat, and a choice of bun. Now, whatever meat I choose doesn't really affect my decision for bun. Okay, so this is what we call an independent event. So we're going to kick this dependent event to the curb. Independent event right here. And how many different combinations are there? That's what we're going to figure out of the meat and the bun are possible. And it's pretty easy. There's a couple different ways that we're going to do it. we're going to settle down on one way for the most part. Well, our meats, first of all, we're going to use a tree diagram, and I'm sure you guys have done something like this before, so it's nothing new really. Our meat choices were hamburger, chicken, or fish. And if I choose hamburger, I got two choices of bun. I got plain or sesame seed. And we'll go P for plain and S for sesame seed. And also the same thing for chicken. P for plain, S for sesame seed, plain, and sesame seed for fish. So really our outcomes are this. HP means I got a hamburger on a plain bun. HS, hamburger on sesame seed. And then so on and so forth with the chicken. And the fish on a plain bun, or fish on a sesame seed. And these are our total number of choices here, our total number of outcomes. And you can see 1, 2, 3, 4, 5, 6. There's 6 different possible outcomes when choosing from 3 different types of meat and 2 different types of bun. Now, that leads us into this. The fundamental accounting principle. Fundamental accounting principle is this: if one event can occur in M ways and another in N ways, then the number of ways both events can occur is equal to M times N. So basically, you take the number of possible ways an event can occur for both situations and you multiply them. So looking at this problem here, well, how many different meats do we have? 3. How many different types of bun did we have? 2. So the number of sandwiches, possible sandwiches we could come out from these 2 events are 3 times 2, or 6. Same thing we had over here. So we're generally not going to do a tree diagram for all these problems, but it kind of shows you where the 6 comes from for this particular problem. And also, you could do this with more than 2 different events. You could have 3, 4, 5, 10 events. It really doesn't matter. And in fact, let me see here. If you go back to this problem, okay, how many different Minnesota state license plates are there? Well, the first letter here can happen 26 different ways, 26 different outcomes. Second one, 26 different outcomes. Third one, 26 different outcomes. And then the numbers, the digits, you can have 0 through 9. This is going to be 10 times 10, and finally last number would also be 10. If you multiply these all up, total number of possible outcomes would be 17,576,000 different license plates that you could possibly come up with in the state of Minnesota. So, and now you got the loon license plates and the deer license plates, and there's all kinds of different license plates. So that's also going to make a change. But with this the standard Minnesota state license plate, this is kind of what we're looking at. Okay. Next problem. To check a voicemail, owners may have to enter a 3-digit code. Determine whether choosing each number is an independent or dependent event. Then determine how many codes are possible. Well, when you're doing these codes, it really doesn't, one event doesn't affect the other. Like if I choose a 1, that doesn't mean I can't choose 1 for the second digit in the code. So this is going to be, once again, an independent event. Now it's a 3-digit code, so it means there's going to be 3 numbers in the code. Okay. Now choices, you got to remember, for each digit you can choose 0 through 9. So that's 10 choices. 0 through 9, 10 choices. And 0 through 9, 10 choices once again. According to the fundamental accounting principle, if you have 10 different ways for each one of these, 10 times 10 times 10 is going to give me 1,000 different possible codes or to get into this voicemail. So there we go. independent event. Let's see if we can come up with a dependent event here. Carly wants to take 6 different classes next year. Assuming that each class is offered each period, how many different schedules could she have? Well, so she's taken 6 different classes, so it's a 6-period day evidently. Now, one choice does affect the next, because if she chooses Spanish first hour, she's probably not going to take Spanish again third or fourth hour. So one event does affect the next. So this is going to be a dependent event. Now, so there's 6 different events going on here. And number of choices. Well, she's got 6 classes that she wants to take. So how many choices does she have for first hour here? She has 6 different choices. But she's going to pick, let's say she picks Spanish. She can't pick Spanish anymore, so she only has 5 choices for the next class. Let's say she picks math, because it's probably the best subject ever. So math and Spanish are gone, that only leaves 4 choices, and so on and so forth. She's going to have 3 choices for this hour, 2 choices for 5th hour, and only 1 choice, 1 class will be left for 6th hour. Multiply all these numbers up, because even dependent events, you're going to use the fundamental counting principle on, and multiplying these all up, and we get 720. 720, and I think that's all we're going to do for today. If you have any questions or concerns, write them down. We'll go over them tomorrow, or when we go over these notes for the first time, and we'll see you in a little bit.